All right, what's going on, everybody? It is Kistner back again, and we are going to today look at 4.5 solving rational equations. Now, that will be on page 110, I believe, in your student companion. It actually starts on 109, but we're going to start on page 110. So we're going to get right into this. Now we're going to be solving them. Everything we've done up to this point has been adding, subtracting rational expressions, uh, things that don't have equal signs on them with them. So now we're going to look at the ones that do actually have equal signs, and we're going to be solving for things now. So you're going to end up with x equals something, or whatever variable equals something now. So let's get right into it. Example 1, solve a rational equation. What is the solution to the rational equation? Okay, so once again, let's go way back to when we first learned how to do this with fractions. If we had something like 2 over x equals 4, what we would do is we pretend that was over 1, cross multiply, get 2 equals 4x, divide by 4, and get x equals 1/2. That's exactly what we're going to do. We're going to cross multiply when we can. Okay, when we can, that's kind of what we want to go for here, is cross multiplication. So let's look at this example. So we have 2 over x plus 5 equals 4. So if I picture this as being over 1, you don't have to do the over 1 part every time, but if I cross multiply, I get 2 equals, and this whole thing gets multiplied times the 4. And this is where a mistake is easily made. Okay, it'll end up looking like that, 4 times x plus 5. Not 4x plus 5, just 4 times x plus 5. You actually have to multiply the whole thing. So now you have two options. I'm going to go both ways with this. One option is to come over here and divide through by 4. So you're going to get 2 over 4 equals x plus 5. Okay, so that's 1/2 equals x plus 5. Subtract 5, and 1/2 minus 5 is, what's 1/2 of that? It's going to be negative 9/2. If you do the math, you can use your calculator for that part. But the other way to do it would be to distribute. So I'll show you the other way. We'll have 2 equals, and then when we distribute the 4, we get 4x plus 20, and now it's just a simple solving. Over here, we divided by our coefficient and got 2/4, and here we're going to distribute. It's going to end up the same thing. Just this is going to take longer. We subtract 20, get negative 18 equals 4x. Divide by 4, divide by 4, you get negative 9/2 equals x. Same answer both times. We'll do part B in class together. So here's a work rate problem. Now these are word problems, so they immediately cause people to not want to do them, but they're not that hard, I promise. It takes 12 hours to fill a pool with 2 pipes, where the water in one pipe flows 3 times as fast as the other pipe. How long will it take the slower pipe to fill the pool by itself? This is such a typical question. All right, so we're going to let x be the number of hours the slower pipe takes to fill the pool. Okay, x is the number of hours it takes to fill the pool. So we know that the slow pipe can fill one pool in a certain amount of hours. Okay, so let me rephrase that. It could fill one pool in x hours, slow pipe. Another way to say that is it can fill 1 over x of the pool in 1 hour. Okay? Now the way that works is, imagine you can do one homework assignment in 2 hours. Okay, so in 1 hour, you could do 1/2. So like make this a 2. So if you could do one pool in 2 hours, you can fill half of it in 1 hour, because 1 hour is half of 2. It's the same kind of thing. Okay, we know the fast pipe is twice as fast. Sorry, 3 times as fast. So we know that it's going to be 3 over x in 1 hour. Okay, because it's 3 times as fast, 3 times this. I'll show that here in a second. It'll be 3 times 1 over x. It's 3 times as fast, which means 3 over x. So when we add these together, it takes 12 hours. Okay? Or together, they can fill 1/12 of the pool. The hours are on the bottom. How much of it is on the top? Okay? So this is how most work rate problems are going to be. All right, the thing you don't know is going to be on the bottom. So when we add these together, this is pretty easy. This is 4 over x equals 1 over 12. We just have to solve for x, because x is the number of hours the slower pipe takes to fill the pool, which is what we're looking for. How long will it take the slower pipe to fill the pool? So now we cross multiply, and we get 48 equals x, and we're done. It'll take 48 hours. So let me go back through that, because that was kind of confusing. It takes 12 hours to fill a pool with 2 pipes. So I know when I add these 2 pipes together, it's going to take 12 hours. So we can't forget that. Where the water in one pipe flows 3 times as fast as the other pipe. So we have a slow pipe and a fast pipe. How long will it take the slower pipe to fill the pool by itself? Well, we know that the slow can fill one pool in so many hours. We don't know how many hours. That's the x. So in theory, it can fill 1 over x in 1 hour. So like I said before, that's like saying you can do 1 in 2 hours. So how many can you fill in? So you can fill half of it in 1 hour. Let me change the numbers there. Maybe make it a little bit easier. We did 5 hours. You'll be able to fill 1/5 of it in 1 hour. 1 part of it in 1 hour. Okay. This one's 3 times as fast. Okay, this is not our actual data, so I don't want us to get confused. This is 3 times as fast, so it's going to be 3 times the slow pipe. We add them together, we cross multiply, and we get 48. That's how you do that. We'll look at another one of those for sure, because those are really good application problems. What is the solution to the equation? All right, now this one gets a little bit more complicated, because it has 2 expressions, and we don't have a common denominator yet. All right, so let's find a common denominator. Now, it's nice that they kind of listed it for us over here. X plus 2 and x minus 2, they will combine. Remember, our least common multiple is when you list each one, and it's x plus 2, x minus 2 already over here. So all we have to do is multiply. I'm going to rewrite this so we can do some work with it. 1 over x plus 2 plus 1 over x minus 2 equals 4 over x plus 2, x minus 2. Okay, so what I'm going to do here is multiply the top and bottom of this one by x minus 2, and the top and bottom of this one by x plus 2. And the bottom here by x plus 2. All right, now, when I do that, I'm going to get x minus 2, and there's the plus sign, x plus 2, all over x plus 2, x minus 2, there's my common denominator, equals 4 over x plus 2, x minus 2. Okay, so now, when I cross multiply here, it's going to get kind of messy. But I don't want to do that yet, because I can simplify some things in the numerator up here. Because it's addition, I can get rid of the parentheses. which I'm going to do like this. This is x minus 2, x plus 2. So I have x plus x, which is 2x, and negative 2 plus 2, which is 0. So this is just 2x over x plus 2, x minus 2, equals 4 over that same denominator. And now I can cross multiply, and I'm actually not going to distribute. You'll see. I'm going to say 2x times x plus 2, x minus 2, equals 4 times x plus 2, x minus 2. Now we're going to start doing some division. When I start doing some division, remember, all I want on this left-hand side is the x. So everything that's not in these white parentheses right now needs to go away. So I would divide through, and you can do it all at once. You can divide through by everything that's not those parentheses. And I'll do something different here. I'm dividing through by 2, x plus 2, and x minus 2. Because that's everything over here that's not an x. That's not inside these parentheses. I want this by itself. And that's going to leave me with x equals. Because on this side, the 2's will cancel, the x plus 2's will cancel, and the x minus 2's will cancel. But if I do it to one side, I have to do it to the other. So I have to divide by 2, x plus 2, x minus 2. The 4 and the 2 cancel to give me 2. That cancels here, that cancels here. So x equals 2. And I'm done. Pretty simple. You just have to find a common denominator and combine like terms. All right. So, what are the solutions to the following equations? Now, I'm going to rewrite this once again just so I can do some work with it. Okay, so my common denominator here is going to be x minus 3. That's what two of my fractions have, and I'm missing it on this one. So I'm going to multiply here. Remember, this is like it's over 1. So I'm going to multiply here by x minus 3, x minus 3. Okay? And what I'm going to end up with is x times x minus 3 plus 6, that's the numerator, all over x minus 3, equals 2x over x minus 3. Okay. Now, I could go ahead and cross multiply, but it gets messy, and I see that I have my part B over here, so I'm going to kind of move over to the side. I'm going to go ahead and combine things up here. I'm going to distribute this, and then I'm going to add the 6. So really what I'm going to have here is x squared minus 3x plus 6 all over x minus 3. You don't have to put it in parentheses if you don't want to. Equals 2x over x minus 3. I like to do that because I'm going to be doing some multiplication. Now, this numerator is a quadratic, which can be factored most of the time. But in this case, I don't believe this one will factor. So what I'm going to do is I'm going to come through and I'm going to multiply. Because they have the same denominator, I can come through here, and actually I could have done it up here. Once you get a common denominator, you can do this. So I could have up here, and I'm going to do it here, multiply this by x minus 3, and this by x minus 3. I'm just scaling it up by a term of x minus 3, and what happens is the denominators cancel, and I'm left with x squared minus 3x plus 6 equals 2x. Now that's kind of a hack or a little shortcut that a lot of people don't talk about. You can get rid of your denominators if you just multiply both sides by the same thing. You're keeping your equations balanced, to use a chemistry term. Now this won't factor. This right side, sorry, this left side won't factor. But if I subtract my 2x from both sides, I get x squared minus 5x plus 6 equals 0, and I believe this will factor. Okay, this will. This will factor into x and x. What is that going to be? 3 and 2. and they're both negative, equals 0. So I get x equals 3 or x equals 2. Now, I got two answers here. So I have to check something. Okay? What I have to check is, do they both work? So I'm going to plug 3 and 2 back into my original equation. Now, the easiest way to do that is to use a calculator. So let's get out our calculators. Okay, so I'm going to type this equation in, but every time I see an x, I'm going to hit a 3 or I'm going to hit a 2. So what should happen is the left side should equal the right side. We have to go back to the original equation just so we know that we're not forgetting or we haven't canceled anything out. So I'm going to say 3 plus, and then I'm going to go into alpha y equals and get my fraction key. 6 over 3 minus 3. I think there's an issue right there. That's going to end up being 0, and that's should give me an undefined. I can't do that. That's quit. So I can't. That's bad. 3 is not going to work, and you're going to get a 0 on the bottom too. If we had started off by listing our domain, we would have known that 3 cannot be part of our answer. Okay, but let's make sure 2 can be. Sometimes they don't equal each other. So 2 plus, and one way to do it without the fraction button is 6 divided by, and in parentheses, 2 minus 3. The same thing as what I would have typed in like this. This is this. So we got negative 4. Okay, so if the right hand side does not give me negative 4, 2 is also not a solution. Okay, so we're going to say, and I'll use the fraction key on this one, alpha y equals, no, that's not what I wanted. Alpha y equals n over d. I'm going to say 2 times 2x over 2 minus 3. That is also negative 4, so 2 is a solution. So down here we would say the only real solution is x equals 2. 3 is what we call extraneous. And I'll explain this more in class next time I see you guys. I do want to apologize for the longer video today. It's been a while since we've had one, so I wanted to make sure we understood this. I hope you guys have done your work, and I will see you guys next class. This is Kistner out.